Alright, we will do error handling now. We are inside exercises, error handling, errors 1. And I've opened it already. This function refuses to generate text to be printed on a name tag if you pass it an empty string. It would be nicer if it explained what the problem was instead of just sometimes returning none. Thankfully, Rust has a similar construct to option that can be used to express error conditions. Let's use it. And as you can see here, it's basically returning option, but what's meant here is actually result, and this is also an enum result. It has generic types, type T and type E, and if the return value is okay, or is if the return value is not an error, it will return okay and the value itself. If it is an error, it will return error, and it will, here inside will be the error. So we'll go into that. As you can see, as of now, option string. So when this function over here, generate name tag text, if it gets past an empty string, it will just return none. But we want to be more explicit of why it failed. So, and here, if there is a string indeed, it will return some and a formatted string. So, as you can see here, the test. So the function will get called with this string Beyonce. It will be put into a string type, and then the output should be okay, and hi, my name is Beyonce, which will be put into a string. Now, if we put an empty string and pass it to the generate name tag text, the error should be, or the output should be, error, name was empty, it must be non-empty. So first we have to change the result or the return value, which will be in this case result, and then the result will hold either a string or a string, because we can see over here it has basically two types. One type for the value if it is okay, and one type for the error if there will be an error output. So, and as you can see, if it's okay, we are returning a string, and if it's an error, there will also be a string returned. So basically we can change this over here to be okay, and over here we can change it to error, and then what we can do is basically just copy this value inside here. So I will copy that, and I will put it inside here. Alright, and this of course should also be formatted, so I will do it exactly like this one, format, and then over here we will have another one like that. and it's compiling, as you can see. So the return type is alright, result string string. This is in case it's okay, we pass it a string. This in case if there is an error, we pass it a string too. Alright, let's go to the next one. Say we are writing a game where you can buy items with tokens. All items cost 5 tokens, and whenever you purchase items, there is a processing fee of 1 token. A player of the game will type in how many items they want to buy, and the total cost function will calculate the total number of tokens. Since the player typed in the quantity, though, we get it as a string, and they might have typed anything, not just numbers. Right now, this function isn't handling the error case at all, and it isn't handling the success case properly either. What we want to do is, if we call the parse function on a string that is not a number, that function will return a parse int error. And in that case, we want to immediately return that error from our function and not try to multiply and add. There are at least 2 ways to implement this that are both correct, but one is a lot shorter. All right. Excuse me. So first thing, we will import the parse int error. So this is a type, and we have here, as said, we have here a function total cost. It will expect an argument of type string slice, and then it will return a result with integer types if the result is okay, and if it's an error, it will return a parse int error. That's this type we have imported. So let's see, let processing fee equals 1, let cost per item equals 5. Let quantity item quantity dot parse I32, and then we have here okay. This is in case everything is successful. We will multiply quantity with cost per item and then add processing fee. All right. And now the easy way really is just to add here a question mark, and it should compile. As you can see, it's compiling. This question mark I show you in the book. So this question mark over here, basically what this does is the question mark operator follows the result value returned by file open, but this main function has the return of not result. Okay, no, that's not a good definition here. All right. This implementation uses the question mark operator. The question mark operator placed after a result value is defined to work in almost the same way as the match expressions we defined to handle the result values. If the result or if the value of the result is an OK, the value inside OK will get returned from this expression, and the program will continue. If the value is an error, the error will be returned from the whole function, as if we had used the return keyword, so the error gets propagated to the calling code. So basically what this says is we can use this question mark operator to check. This here will return a result. So parse will return a result. As you can see here, I had it open. Parse, this method, will return a result type. And all this does is, it basically is kind of unwrap. If the value is okay, this value, the I32, will get passed to this variable like that. So this variable will hold I32. Let's see if it's compiling. As you can see, that's all right. Now, if this is failing, so it tries to parse. For example, here we pass the letter A, and this cannot be parsed into an integer. So what this does, it will return, and it will return this error. So here it will implicitly return, so this will never get executed. It will go out of this scope of this function and just returns parse int error. Now there is the more verbose way, and that's basically with a match statement. So we can match quantity here, and if we have okay and we get the quantity, we basically just do that over here. So we pass that and we do it like that, like so. And if it's an error, we will pass it like that. And as you can see, it's compiling too. So this is the more verbose way. In this case, we have here the value quantity, and this of course will hold type result. All right, and in the result will be I32, or there will be parse int error, I guess. Let's see if that's right. Right, so this variable will hold a result, because parse, as I've said, will return a result. Either it will be okay and it will hold then I32, or parse int error in case of failing. And all we do then is just basically unpack this. So as I've said, quantity, this variable holds a result, and we want to get the value out of the result. So we match quantity. If it's okay, then we just do what we want to do, multiply quantity with cost per item and adding processing fee. If there is an error, we will just return the error, which in this case will be parse int error. And this is, of course, handled by this method parse. So you can do it either way. I will uncomment this one, or I will comment this out, and I guess I will just put that over here, so like that. Nope, I have to actually show it like that. I like the first one a lot more, so basically all we did was that, I guess, and it should actually compile, as you can see. So this is a lot more simple, and you see all this code really is not needed. But as I've said, you can choose whatever you wish and both will be correct. All right, let's go to the next one. We have a lot of work today, so let's see. This is a program that is trying to use a completed version of the total cost function from the previous exercise. It's not working though. Why not? What should we do to fix it? So over here, again, we are importing the parseInt error type. And here, basically, as you can see, this is the exact same function we have had in the previous exercise. So I won't go through that a second time. But as you can see here in the main function, we are actually calling the function directly. So in here we have a variable tokens. That's the amount of tokens we have. It's mutable. Then we have pretend user input, and I will just annotate this. So this is of type string slice. So this is not a number, or this is not an integer, it's a string slice, pretend user input. So mostly if you give users to input something, they can basically just type anything in there and you have to handle that. So here we have a string. And then what we do here is we call this function total cost with this pretend user input 8. This again is a string. So we call that. And then this will get processed. And we then return over here result I32 or parseInt error. Why? Because that's the result, or that's the return value of this function. So we call this function and we'll return that one. So we have this inside our cost variable. And as you can see, basically we here have the question mark operator. So if this fails, if this function calls returns a parseInt, we will immediately stop the program. And if it's a okay value, let me change that one because that's not right what I've said. This will return result I32 and parseInt error. Now because we have here question mark, actually it will unpack this value if it's okay, and if there is an error, the program will stop executing and return an error. And then it basically checks if cost is more than tokens we have, you can't afford that many, and else the tokens will be decremented by the cost, and then we basically say how many tokens will be left. All right, and of course, because we have here a question mark operator, and that's very important to know, we have to return a result, because else this is not working. If you see this, the function must return a result, or an option is also possible, but you mostly see it with results. So because this is a main function, we actually don't return anything in case it's successful, because you know if it's the end of the main program, the program will finish. So what's the point of returning something from main? But if there is an error, we will return a parse int error, like that. So this is basically just a unit-like struct, and it holds no value whatsoever. And that's what we want, because as I've said, when main ends or finishes, your program is done. There is nothing more the program will do. So, and parse int error in case this returns an error, like that. And of course, because we have here said that result, in an OK case, we will just return a unit type. We just have to return that one. So we return in the end just OK with a unit-like struct, like that. Let's see. And as you can see, it's compiling. You now have 59 tokens. So why 59? Let's see. We have 100 tokens. Then the user inputs 8. So this will get passed over here. So we have 8 over there. Processing fee is 1. Cost per item is 5. So then the 8 will get parsed into an integer. That's like what we did last time. And then what will we do? We will multiply quantity, which in this case is 8, times 5 is 40. And we add 1, which is 41. So then in here, this will be 41. And then we basically check if cost is more than tokens. In this case, it's not. So 41 is less than 100. So we go into the else block. So we just basically decrement 100 by 41. And that's, of course, 59. Like that. All right. And let's see, next one. Here we don't even have an assessment. Let's see. Okay. Here you can see we have a struct positive non-zero integer, and here we have unsigned integer 64 bits. Here we have an enum creation error with one negative and one 0. Then we implement for this struct positive non-zero integer a method new, and it expects a value of type integer 64 bits, and it will return a result with either positive non-zero integer, that's this type, or a creation error. So, why is this only returning an OK value? So, and here we have a test creation. So if we call that positive non-zero integer, the method new, that's what we have to implement here, with 10, and is OK. So this should actually be OK, because 10 is not negative and not 0. And if we pass it a negative value, it should return an error with creation error negative. That's this enum with negative. And the same thing basically for 0, it will return error, creation error 0. So what will we do here? Basically, all we have to do is just checking the value, so match value, and I will show you two ways, in fact. Let's see, I will do the first one, so 1 to infinity. If value, this we are passing here, is 1 to any other number higher than 1, we will just return that one. So as you can see, we are returning that one. And if it's 0, then we will return error, creation error, 0. And if value is below 0, so actually we can just put this here because it's clear. If it's bigger than 1, we have handled that. If it's 0, we have handled that. So anything else will actually be negative. So that's simple logic. And error, creation error, negative, like that. All right. Let's see. And the code is compiling. So as you can see here, basically we just get a value and then we match the value. If it's 1 or any other number bigger than 1, we will return OK. And positive non-zero integer and the value as an unsigned integer 64 bits, because that's what is required by the struct over here. If it's 0, we will return error, creation error, 0. And if it's anything else, basically negative numbers, we just return creation error, negative. So this one will be returned. And this is basically just a placeholder because we are not using anything here, so we can just use that as a placeholder. This, you can imagine like the else statement, so this is just in the end, and this will basically be a placeholder for any other value. All right, and the second approach to this, it's actually also a match statement, but it's a little bit different, and I want to show you that. So let's organize code a little bit here, like that, and we have here our second match. We again match value, and basically what we do here is firstly we check x, and x is just, we are taking the value out. I will show you. If x equals 0, or let's say, or yeah, let's make it like that. If x equals to 0, we will return error, creation error, 0, like that. If x is less than 0, we will basically return error, creation error, negative, and else we will just return x. So okay, positive non-zero integer and x, like that. And this should also compile. Okay. All right. Now we want this to be as u64 like that. And it's compiling, as you can see. Why we have to do that? We have to infer this value or to convert it to u64 because, as I've said, in the struct it's required, and here value is i64. So that's basically what we did over here too. And here it's basically the same thing. You know, you have some logic over there. We match the value that's get passed, and we take x if x equals to 0. So x basically is the value. And if it's equal to 0, we will return an error, creation error 0. That's from the enum. If x is less than 0, we return creation error negative, and else we just take x and we return okay, positive non-zero integer, and we return or pass this struct over here x as an unsigned integer of 64 bits. So you have two ways over here and over there. I like that a little bit more because it's kind of more clean to me, but if you prefer less code, you can get that one as you prefer. It doesn't matter really that much. All right. And we are in the fifth one. This program uses an altered version of the code from errors 4. This exercise uses some concepts that we won't get to until later in the course, like box and the from trait. It's not important to understand them in detail right now, but you can read ahead if you like. For now, think of box din or dynamic type as an I want anything that does question mark type, which given Rust's usual standards for runtime safety should strike you as somewhat lenient. That's right. In short, this particular use case for boxes is for when you want to own a value and you care only that it is a type which implements a particular trait. To do so, the box is declared as of type box dynamic trait, where trait is the trait the compiler looks for on any value used in that context. For this exercise, that context is the potential errors, which can be returned in a result. What can we use to describe both errors? In other words, is there a trait which both errors implement? All right, and let me zoom out a little bit. So we have here like that. All right, and yeah, it's not that big. So again, we have here our imports. We import from the standard library, error, format, and parse int error. Again, that's the type. So to do, update the return type of main to make this compile. So we have here main function and it will return, we have already seen that one, result, a unit like struct, and then here, as in the description, a box din, and here we have to give it a type. And as it said, box is basically a smart pointer. And don't worry if you don't understand right now, I will explain that in future courses, but it's a smart pointer that will point to some value in the heap memory. And here what that says is basically din stands for dynamic, and here we give a trait, name of trait, and this basically says we can pass here any type which implements a specific trait. And again, don't worry, this might seem a little bit weird, but you will get what this means. All right, and here let pretend user input. We have already seen that. Again, this is of type string. This is not an integer. Then here pretend user input parse. So this gets parsed. And again, as you can see, we have the question mark operator. So this will either return I64 or it will return a parse int error. And then this value x, here we have a print line which basically prints this struct over here, positive non-zero integer, and we pass x to this method, and again we have a question mark operator, and if everything is all right, we just pass OK and an unit like struct, as you can see over here. So that's all the same. Let me take a little bit of water. As you can see, we have struct positive non-zero integer, which takes an unsigned integer of 64 bits. Here we have the enum. We have already seen these two. So creation error, negative or 0. Again, here we have on the struct positive non-zero integer an implement, and we have here the method new, and we already implemented that already. So that's basically what we did. If the value is less than 0, creation error negative. If it's equal to 0, creation error 0. And else we just have a struct with an unsigned integer. And over here, basically some traits get implemented for creation error, so we can actually handle all that. And you know, I won't get into it too much because that's way ahead of where we are. But basically, you see, we have here from the standard libraries some traits, for example, display or error, and they get implemented for our creation error enum. That's basically it. All right. And yeah, what we basically have to do is, let me see. We have to just implement that one, I guess. So basically we have to find out, because this here, pretend user input parse, this will return a result, as I've said over here. Here you have it, result. Parse method, here we have a result. So this will either return a result or an error, and the error will be a parse int error. Now here we have also question mark, and if this fails, we return, as you can see here, the new, we return creation error. So the problem is we can't write here, if you for example, we have here parse int error. Now that's all right, for this case. But for this case, this will return another error type, which is of type creation error. So this won't work. So we basically have to put in here these two types, but it's not always the case that these two fail. Maybe this passes, but this one fails. Or maybe this one fails and this would pass if this passed. So that's not working over here. And what we basically have to just do is, and that's also why parse int error actually implements the error trait. And here, as you can see, we have implemented error for creation error. So we have implemented this trait for that one. And we just basically type here error and we access the error trait. So this will get covered and this will get covered. So because both errors, this in case of an error will return parse int error, and this is from the standard library, so of course it implements this trait. And as you can see here, new, when it fails, it will return creation error, and creation error also implements this trait. So all we have to do is basically here tell the compiler that we accept any type that just implements this trait. And really, this exercise, I don't know, I think it's way ahead of what we've learned so far, and I think this should have been to a later time, but let's see. Actually, as you can see, it's compiling and the output will be output equals positive non-zero integer 42. But again, don't worry too much about that. I don't understand really why they put it into here. You don't know about traits so far, so this is rather confusing. But yeah, and why is it actually returning 42? Because that's what we have passed over here. So basically everything succeeded. So we have here a string which holds 42. It gets parsed, then it will get parsed into an I64, and then we create a positive non-zero integer struct with the new method and pass it this value, which is 42, and of course it's an integer. This will get passed here, and in the end we will basically have a positive non-zero integer struct which holds 42. And again, because we are in the main function, we just return OK and an unit like struct. And this result here is more in case of an error. In the main function, you don't want to return something because it's basically useless. All right. I guess we are now in the last one. And that one looks quite big, so let's see. Using catch-all error types like box dynamic error isn't recommended for library code where callers might want to make decisions based on the error content. Instead of printing it out or propagating it further, here we define a custom error type to make it possible for callers to decide what to do next when our function returns an error. All right, so again, here you can see from the standard library, parse int error type. Then here, this is a custom error type that we will be using in parse pos non-zero function. So we have an enum parse pos non-zero error, and it holds two members: creation, which has a type of creation error, and parse int, which has a type of parse int error, and that's the one which was imported over here. So then for this enum, we are implementing a method from creation, and basically here we see error. This is an error argument, so we expect an argument of type creation error, and it will return parse pos non-zero error, basically this enum type. So as you can see here, this will be the return value: parse pos non-zero error creation, and then we pass here the error, which has to be of type creation error. Now to do add another error conversion function here, and here we will create a function called from parse int. Okay, and here we have parse pos non-zero. This expects a string as argument, and it will return a result which holds positive non-zero integer. That's this struct over here, unsigned integer 64 bits, or in case of an error, it will return parse pos non-zero error, basically this type, the enum. Okay, to do, change this to return an appropriate error instead of panicking when parse returns an error. All right. And as you can see here, we have a variable x which holds a value of I64, and again we parse this string and then unwrap, and then positive non-zero integer, that's the same thing we have over here. I think you remember we pass x to here, and then we have here map error, and then we basically call this function over here. Let me see. We call this function from creation, or we pass it this function. We are not calling it, we pass it. And let me just show you what that means. So map error, and maps a result te to result tf by applying a function to a contained error value, leaving an OK value untouched. This function can be used to pass through a successful result while handling an error. So basic usage. As you can see, we have here a function stringify. It takes a value of u32, and then what it basically returns is a string, and it just returns a formatted string which says error code, and then the integer that gets passed to this function. And as you can see here, we have OK. This is a result OK. So this will hold a result of type unsigned integer, and x here holds this value. So we can x map error and then pass it this function stringify, and then nothing will happen here. Why? Because leaving an OK value untouched. So nothing happens. When you call this X, you call map arrow stringify, this will be the output. It is untouched. Nothing will happen to this. Now, if it's an error and we call X, which holds this error, and we call map error and pass it the stringify function, actually this error will get passed over here. So it will then take 13 as X and then just prints it or returns the string which was formatted. So basically what it returns is error and then the return string from stringify function error code 13. So that's basically what this says. So again, as you can see here, we have positive non-zero integer and then new, we call it this, and then map error. So in case this returns an error over here, which will be a creation error, we will call upon it this function. So what this then will do is it will take the creation error and it passes it to this enum under creation, and then this error will be inside of here and it just returns that. Right, and let's see, we have here the tests. So parse pos non-zero. Let me see, what's this one? That's the function over here, parse pos non-zero. If we pass that a string which is not a number, it should return an error, parse pos non-zero error. And what's that name like? It's even hard to pronounce and just too long, but anyways, parse pos non-zero error, and it will return parse int. So that's basically this one. And yeah, the rest is actually quite the same. If we pass a negative value, we will have this parse pos non-zero error, creation error, negative. So as you can see, it's basically, we have started only with that, then we have had this, and now it gets built up. So if we pass 0, it should also be creation error 0, and if it's just a normal amount above 0, then of course it's okay, it will return okay, and yeah, that's basically it. So what we can do over here, I will make that full screen, and maybe I will just zoom out a little bit so I can actually split the screen here like that. And let's see, I want to see the tests, this one of course, like that. All right, and yeah, I hope you can read it, but I need to see that. So first thing, we will basically implement this function. So let me just delete that, and then as above, here you can see in the example, we expect an argument error which will be of type parse int error, and this should then return parse pos non-zero error, which will be parse int, and then we will pass it error, like in the one above. So let's see. We return parse non-zero error, and it will be parse int. That's that one. And then we just pass it the error over there. And then to change this to return an appropriate error instead of panicking. I guess I won't even need that, so let's close here. Now I'll do it like that so I can see it better. Here we have unwrap, but I guess this is failing. As you can see, test parse error. So this doesn't return the right error we are needing. So let me actually do it like that. So like that. So we basically do the same map error, and we will call, or we will pass it the parse non-zero error. This is this enum with these methods, and we will call the method, or not call, we don't call the method, we will pass the method to map error. So map error will then map the error like that from parse int. And actually this of course has to have this question mark operator, because as you can see we are expecting here I64, and so basically, as you should know as of right now, if this returns an error, we will return, and if it's okay, we then have inside this x an I64 variable. So let's see. And it's compiling. All right, and maybe just for clarity's sake, so we could have removed that and just shadow x. So no, this will then return a result with either I64 or a parse non-zero error, I guess. Let's see. Right, and then what we can actually do is we shadow x, so we redeclare x. This time we are expecting that, and this will be match x. So we are matching this x, and if it returns an OK and we have a value here, we are just returning that value like that. And if it's an error, we will return a parse non-zero error like that, and that should actually work too. And of course this should be parse non-zero error. Or no, I'm sorry. We just pass the error like that, because we have the value over here. And of course, we have to make that. We have to pass the error like that. As you can see, it's also compiling. And as you can see, basically what we did here was accomplished by just appending over here a question mark. Now this is of course not true anymore, so let's delete that. Right, so all we did over here is basically accomplished with this simple question mark. So as you can see, it's really something great, but let me just explain what we did over there. So basically, as you can see, we take S over here, we parse the string, so we should get a integer, and then we map error. So in case this parse will return a result, as you know, this will return a result. And if this returns an error, we basically call, or we pass it to that function over here from parse int. And then we have the error over here, and we just basically put it then in the enum parse int, and here will be the error like that. And then, as you can see, we have here inside variable x a result of type integer 64 and parse pos non-zero error, because we have mapped over this error and returned this error type like that. And then what we do is basically redeclare x, and we want x to be I64, so we can pass it to here, because positive non-zero integer new expects an I64 value. So we did that, and then we basically match x, so we want to get these values out of the result. So if the result is okay, we will just get the value out and put it into here. Now if it's an error, we explicitly return the error like that. So we basically return here means we are going out of there. This never will be executed because we are returning. And if everything's fine, we have here x I64, and we pass it over here, and then the same thing basically. If everything was okay, we have then a struct which holds an I, or an unsigned integer 64 bits. And if there is an error, we map it, and we map the error over here to this from creation, and we have the error inside the argument over here, which is of type creation error. And then we basically just return parse pos non-zero error creation and error, this argument over here. So all right, we are done. And as I've said, this is really verbose. So just use over here this question mark. We don't need that one, so delete that. As you can see, we can accomplish all of that with just this one. All right. We are done, and our next topic will be generics. See you then.